Thank you very much. I appreciate being here. One of my reasons for becoming, again, involved in the instruction courses related to metal detoxification was my interest in making sure that you folks knew to prepare your patients prior to mobilizing metals, especially mercury. The chelator we use for lead, the EDTA, really wraps that molecule. My image is it really wraps that molecule up, and so it doesn't have as much of a chance of creating oxidation stress as it mobilizes. However, with the other chelators, there is some chance of increased oxidation stress, and I had seen back in 95, 96, 2 people that had been given DMPS without any preparation at all. They'd had their amalgams removed, went from the dentist's office to the doctor's office. They gave them a big push of DMPS, and they started having headaches and feeling poorly that dragged on for several weeks. And because of my interest in mercury, they were sent to me. And on the intracellular white blood cell analysis, these 2 people were low in glutathione. And so I started looking into glutathione, and as we raised their glutathione levels back at that time by giving them precursors, the NAC, for example, they began to improve, and we also gave them intravenous glutathione. And it became clear to me that some way of getting glutathione into the system was really important in regard to the metals. As Boyd already mentioned, when you're exposed to mercury, one of the first things that is documented to happen, this happens with lead and the other metals also, is you deplete your glutathione. So, okay, that's the, all right. So as my interest, I became kind of a glutathione fanatic and read about it for about 10 years and then came up with the idea of putting it into a liposome. And I was very fortunate to be able to get a study done in a lab that has specialized in lipid metabolism and vascular disease. Mickey Avaram, who's the professor in charge of the lab, has published over 300 papers in lipid metabolism, and told me just a few months ago that he has now been cited over 11,000 times in the literature. So this was done in an environment that really understands vascular disease. Which button am I supposed to be pressing? Oh, okay. Oh, thanks. Oh, it's the pointer. Ah.
Sorry, low tech.
I got my function. So we've talked about the qualities of glutathione, but in a brief review, it's an antioxidant. It detoxifies by binding to toxins and facilitating their removal. And the GST, in explaining it to my patients, I tell them that's the matchmaker enzyme. Without a matchmaker, you have to go through a lot of encounters to meet the right person. In this situation, it introduces the glutathione to the right toxins. And without the GST being present, you need a lot more molecules of glutathione around to enhance the opportunity for that encounter to occur. Glutathione, as we mentioned, has been involved in mercury removal, and we'll touch on that. It's also been reported to be involved as a mechanism that may help slow, well, it's been reported for the neutralization and removal of mycotoxins. And it turns out to be a cell signal in immune cells. And the cells that make the decision about whether to go to Th1 or Th2, meaning a functional, efficient T cell system, or the cell immunity system, or the Th2 chronic inflammation. If you lower the glutathione, it increases the release of cytokines associated with chronic inflammation. So that's probably where you're hearing about the chronic inflammation that's coming up in people that are depleted of glutathione. We're going to cover a lot. If you have questions, my contact information is drg@readysorb.com, is on your books, and I have a you can contact me after the talk, and I have put out a little card where I can be found. And so low glutathione is associated with a lot of diseases. You've heard about autism. Cystic fibrosis is interesting because that's in the human that they're missing the gene for the protein that carries glutathione and other large anionic molecules across membranes. And if you want to know how important that is, just take a look at a child with cystic fibrosis. They have lung problems because they're not able to put as much glutathione in the extra cellular lymphatic fluid that lines the alveolar sac, and so they build up a lot of mucus and are prone to infection, and they have similar problems in the GI tract, so you get an idea of where glutathione plays a role in the lung as well as the GI tract. In Parkinson's, you have a deficiency of glutathione in the substantia nigra cells as the first indicator of abnormality, and they may have normal levels of glutathione in their blood. So you can have compartments of the body that are low in glutathione while your circulating glutathione is normal, and this has created a lot of confusion about glutathione in general and how to diagnose things. But if you see somebody with Parkinson's, for example, well, you know that they're low in glutathione in that cell area. The same is true in asthma. It's now been shown that children with severe asthma are low in glutathione in the extracellular lung fluid, and so they've got a deficiency localized also. Another area, diabetes, when it's poorly controlled, or diabetes in general is low in glutathione systemically, and particularly when it's poorly controlled. And that's important because the building blocks of glutathione don't work. It's published by an article, the author is Darman, D-A-R-M-A-U-N, and I'm happy to send you the whole article if you want to contact me. And they gave NAC, which is one of the building blocks of glutathione, and it's known to raise glutathione normally, but in these children undergoing severe oxidation stress, it did not raise their glutathione, even when they gave it intravenously. So it wasn't a matter of absorption. And I'll show you some candidate areas where these things are being blocked. And then you heard about viral disease, both acute and chronic. So why do we need glutathione? Well, it turns out that in order for a cell to make energy in the mitochondria, in undergoing the oxidative phosphorylation, it uses oxygen, and about 2 to 5% of the time you're going to end up making free radicals, even in an absolutely normal situation. When you have abnormal problems like an accumulation of metals, you're going to make even more free radicals coming out of your mitochondria. And it turns out that glutathione plays a huge role in preventing damage to the mitochondria, both inside the mitochondria. It's made in the cytoplasm, and there's an active process that carries it into the mitochondria. These reactive oxygen species cause oxidative stress, which will cause damage to lipoproteins, and we'll go into that a little more. But basically, your polyunsaturated lipoproteins are at greater risk, and I'll show you why. And when your membranes get oxidized, this is what happens. In the outside world, even iron chip becomes oxidized, the membrane falls apart. The same thing can happen in the cell, but usually before you get to the point where the cell necroses and falls apart, the body has this built-in mechanism that Dr. Haley went into about apoptosis, so it kind of self-digests those cells to prevent the inflammation that occurs when they die. So glutathione has this prominent sulfur molecule, and that molecule is able to donate an electron, as well as it's able to give off the hydrogen proton. Usually, I only have figured this out recently, but when a molecule donates an electron, usually the proton, the hydrogen, goes along with it. And it offers a unique platform that is more soluble than cysteine. You've got glycine up here, cysteine in the middle that has the SH group, and then glutamine. And the configuration of where the glutamine is attached to this is unique inside the cell, because inside the cell, this is one of the few peptides that resist the enzyme peptidase. So once you have glutathione formed, it's likely to stay in the cell.